Hi folks, today we're going to talk about a new statistical tool that you can use to compare two data sets and see whether one is actually different from the other. So far we've used error bars with things like mean absolute deviation or standard deviation to tell apart our data. So here I've gotten an experiment, and in this experiment I rolled 3 different dice, and I got different sets of numbers on those dice. But this was a situation where I had a lot of variation on the different dice. So for example, in my first data set, I had numbers as low as 1 and as high as 20. And there's a lot of variation there. Because there was so much variation, I ended up with a really big mean absolute deviation. The numbers tended to be very different from the average. That means that when I graphed this and I put my error bars on it, I ended up with error bars that all overlapped. Now, if I'm using mean absolute deviation to look for statistical significance, I wouldn't actually be able to conclude that one of these is better than the other. So we need a more precise statistical tool to tell things apart. There is a statistical tool that lets us do this. It's something called a probability value. Probability values are something that statisticians use to tell whether or not two sets of data could actually have come from the same thing. So imagine I were to roll a single die 20 times. I would get 20 different numbers. Then imagine I roll it 20 times again. I would get another 20 numbers. And those numbers would be different. I would have different averages. One of those averages would be higher than the other, even though it came from the same die. So the question that a p-value or a probability value answers is, what's the likelihood that I could have ended up with these two data sets if there wasn't a difference between the two things I'm measuring? Now, probabilities are usually measured in percentages, so I could have a probability between 0%, these are definitely different dice, and 100%, these are definitely the same die. Mathematically, you represent a p-value with a number. So a p-value of 0 is a 0% chance, and a p-value of 1 is a 100% chance. A high p-value means that there's less likely to be a difference. It means it's more likely that these things are measuring the same thing, that you can't say that one's better or worse than the other. A small p-value means that it's more likely that there is a statistically significant difference. So if I have a really tiny p-value, that means that it's likely that these numbers came from something different, that I can actually say that one is better or worse than the other. Remember, these numbers are going to be between 0 and 1, and they represent a percentage chance. Typically, the line that scientists draw to say whether or not we can claim that these things are different enough for me to draw conclusions is 5%, so that's 0.05. If my probability value, my p-value, is less than 0.05, then I can say that one thing is better than the other. If my p-value is bigger than 5%, if it's more than 0.05, then I can't say for sure which one is better. So the next question is, how do I get a p-value? Well, there are many different types of statistical tests, but almost all of them involve doing a bunch of math, and then at the end of the math, you have this number. You don't necessarily need to know all the math that goes into a statistical test, so long as you know how to read its outcome. If you can look at a p-value and say, this is statistically significant, it's less than 0.05, or this is not statistically significant, it's more than 0.05, that's good enough to get you really far. So, I'm going to teach you one statistical test. The spreadsheet can actually do the math for you. So what's going to happen is I'm going to teach you what to type into a spreadsheet in order to get a p-value that lets you compare two different test groups. Now, the test we're going to be using is something called a student t-test. A student t-test lets us compare two different data sets. Now you can see here in this experiment, I actually have 3 data sets, which means I'm going to need to do this test multiple times. I'm going to do it once to compare set A with set B. I'm going to do it to compare set A with set C. And I'm going to do it to compare set B with set C. So, how you do the actual test. Luckily, the spreadsheet will actually do this for you. You just need to know what to type in. So if I want to compare set A with set B, what I do is you'll notice I've set up a little table here. so that I can keep track of what I've compared and what my numbers are. And remember, at the end we get a p-value. We're looking at that p-value to see if it's less than 0.05, in which case I can say they're different, or if it's more than 0.05, in which case I can't say that they're different. So I'm going to type in equals t-test, parentheses. Then I'm going to highlight all the numbers, all the data points for my first test group, just like I would if I was taking an average. And then I'm going to put a comma in, so now it knows that that's my first test group. Now I'm going to highlight all the data from my second test group. And then I put in a comma, so you can see here it highlighted my first test group and my second test group. These are the two things that I'm going to be comparing. After that, you're just going to type in 2, 1. Don't worry about why you're using 2, 1. That just tells the spreadsheet what type of t-test we're doing. But once I've typed that in, I'm going to close my parentheses and hit enter. Now it's given me this p-value. So my p-value here was 0.045. That is less than 0.05. So that means that I can say that A and B are different because P is less than 0.05. If I look at my averages, I can say that A has a higher average than B, which means I could say that A is better than B, assuming I'm making the claim that a higher average is better. Now let's look at my next data set. I've compared A and B so far. Now let's compare A and C. So again, equals t-test, parentheses, highlight my first data set, comma, highlight my second data set. Here now I want to compare A to C, so I'm going to highlight the numbers for C, comma, and then again, 2, 1. Don't worry about why those are the numbers we use. It just tells us what type of t-test we're doing. 2, 1, close parentheses, enter. Oh, look at the number here, 0.006. That's much smaller than 0.05. I can definitely say that A and C are different, right? So I know that A and C are different because P is less than 0.05. And again, I would look at my averages. My average for A was 10.35. My average for C was 6.11. 10.35 is bigger than 6.11, so I can say that A is better than C. So now let's compare set B and set C. Again, equals t-test, open parentheses. I'm going to highlight my first data set, which in this case is set B, comma. I'm going to highlight my second data set, which in this case is set C, comma, 2, 1, close my parentheses, hit enter. Here it tells me that my p-value is 0.466. Now that is bigger than 0.05, which means what that number actually tells me is that there's a 46% chance that I would get those two data sets if I was rolling the same die. That's not enough for me to say that those two things are different. So what I might say in my conclusion is we don't know if B and C are different. We don't have enough information to tell. I can't conclude one way or another. So that's how you use a student t-test to determine statistical significance. The way you would report this in your summary of results or in your conclusion is you'd say, A and B are different, and then in parentheses say P is less than 0.05. And you might say, A is better than B because A has a higher average. A and C are different. P is less than 0.05. A is better than C. We don't know if B and C are different because P is greater than 0.05. It doesn't mean that they're the same. It just means that we can't tell for sure if they're different. I hope that helped you. Feel free to use a student t-test to tell differences between groups.